Today, we are talking about data architecture. We are in track A in the Data Summit, and it's a pleasure for me to introduce Emma McGrattan. She is the SVP of Engineering at Actian, and she leads research and development for Actian's portfolio. She has almost 3 decades of experience leading a global software development organization focused on innovation in high-performance analytics, data management, integration, and application development technologies. Before we jump into the session, just a few notes on the platform, just in case this is your first session. There's a chat window to the right of the video player. You can chat along with other attendees of what you're hearing in this presentation, and of course, the conference itself. You can also post questions in the chat, and we'll be sure to pass them along to Emma if we have time. You can also let us know of any technical issues that you might be seeing on your end, and we'll do our best to address them. Finally, make sure to check out the networking area where you'll be able to connect with speakers one-on-one and continue the conversation that you'll be hearing. With that being said, Emma, I give it back to you.
Great, thanks, Ruben. It's a pleasure to be here today with you guys. So hopefully you're seeing my screen. And so I want to talk to you today about what we decided were the 5 key traits of a winning modern data architecture. And where we came to this set of traits was in talking to customers and prospects about what they need in their data platforms moving forward. So if you have not heard of Actian, we are a company that's been in the data business for over 30 years. We have many products in our portfolio that we gained through acquisition, technologies including the Ingress database, ParExcel, which later became Redshift, Btrieve, which is an embedded database, but some really great customers that have bet their data business on our technologies. Our products are kind of fall into 3 broad areas. First is the hybrid cloud data warehouse, and that's certainly where we're seeing the most interest these days. I think there was a journey to the cloud that was happening naturally. I think that journey accelerated with COVID as people moved to home office environments. Cloud became much more attractive as a platform. Many organizations have decided that they're moving away from a brick and mortar presence, moving their infrastructure to cloud and moving some of their server over to co-locations. So we've seen a massive acceleration on the cloud adoption. So the next set of products are our mission critical data management. So these are our relational database products, and they power businesses around the world 24/7. And then we have our enterprise data integration technology. So these are technologies that allow you to bring data into whatever your central repository may be. That may be a cloud data warehouse, it may be a data lake. Example use cases for our enterprise data integration technologies include ADP, the payroll provider. They use our technology to onboard all of their new customers. And if you haven't thought about the complexities of payroll, there's quite a lot to it. So it's not just the, what is your salary and any bonus you may be paid each month, but also benefits, right? Making sure that if you get married or have a child, all of that is reflected within your benefits. If you have a special bonus that you've achieved, commission checks and so on. So a very complex environment that we have to get right every month. Nobody wants to be surprised by something being absent from their paycheck. So it's the type of mission critical data integration challenge that our technologies are deployed for. We're really focused on performance, as Ruben already said. We have built the world's fastest analytics platform, and we have started the process of building out a patent portfolio. Previously, we weren't huge fans of patents, but we have learned that protecting our IP is important. So we have over 50 patents in the portfolio already, and because we have a very attractive patent incentive program in place for our employees, we're growing that number all of the time. Now, while we're not a household name, we are in 24 of the Fortune 100, and we have over 3,000 customers globally. Represented on the bottom of the screen are some of our customers. I'm going to pick on the one all the way to the left here, Oxford University. We're used in the clinical trial services unit at Oxford University, and their most recent trial has probably been a fairly bumpy ride for them, is the AstraZeneca COVID vaccine trial. They're actually using our technology to collect all of the information about the participants within that trial, and then analyzing that information to understand where things might be going slightly amiss, and making sure that they understand root cause of any problems with that vaccine rollout, so that they can address those. So real mission critical stuff, and it's for this reason that I thought we were well placed to have a conversation around what we would see as the 5 key traits of a modern data platform. I think Ruben already introduced me. So I've been at Actian for almost 30 years, and I have spent my entire career playing with data. I'm originally from Ireland, although my accent's been kind of lost over the years, and I live on Long Island in New York. So these are what we at Actian believe are the 5 key traits of a winning modern data architecture. So the first is that it's got to encompass all data types and sources. So a lot of organizations are limited in understanding their customers or the opportunities in front of them because they have limits on the data that they can analyze. And that's something that we think should not be if you have defined your modern data architecture correctly. We also understanding the fact that people don't want to pay for peak usage of an architecture, right? They want to be able to deploy an architecture that's truly elastic, and that the architecture can scale in different parts as business needs change. So it may be that you need to quadruple your compute power. You shouldn't have to pay to quadruple the rest of the components of that architecture. So that elasticity we think is important. Being able to self-serve on your analytics, right? So we want to be able to serve the needs of the technical and the non-technical user, to give them the ability to get the answers to their questions that they have about the organization's data. And we believe that's a fundamental requirement of a modern data architecture. We also think that it should deliver value on day one, right? So long gone are the days where people were willing to spend 6 to 9 months investing in building out a modern data architecture and making sure that it worked. 6 to 9 months could just be the architecture side of things, and then you've got to go for the implementation. I think in today's world where we're demanding immediate satisfaction, you've got to be able to deliver value on day one. As soon as people start using this new architecture, they should be able to see that value. And the last thing on here is resiliency. We have long ago moved away from business operations being transacted 9 to 5. People expect 24/7 business operations, and we need to make sure that as you build out a modern data architecture, it's designed in such a way that it can support that and it has that resiliency built in. So what I'm going to do now is to dive into to each of these topics. So if we start with encompassing all data types and sources. So obviously structured data is something that we all understand. It's the meat and potatoes of many organizations, ERP and CRM systems. It's how we would traditionally look at our customers if we're using a database as the vehicle for understanding our customer interactions. We also have semi-structured data. So think about something like you have a contract with the customer, right? The terms of that contract are not exactly collected in a structured form. So there may be some dates in there, some penalties and so on. And what you want to be able to do is to dive into your customer contracts, extract the pieces of it that should be collected so that you can make it part of your analysis of your engagement with the customer. Is there a penalty that you need to pay if you're late in delivering on this? Is it, is time of the essence? Is there a date by which you have to deliver and so on? So that semi-structured data and being able to make sense of it is hugely important. And then all the way to the right here, we have our unstructured data. So this is, if I've had a heated call with a customer and maybe they're very unhappy with, the service that we're providing to them. How do we capture the contents of that call? So probably not a complete transcript. It doesn't tell us a whole lot, but rather what are the key points? How do we measure the tone of the customer? What are the next steps? What are some of the actions that need to be taken as a result of this? So being able to reach into that unstructured data, could be pictures, could be video, anything along those lines, and capture the essence of that customer engagement so that as we're looking at our customers holistically, we get to take more of a 360 view of exactly what their interactions with our company is. So to me, this is hugely important. And if you want to really understand your customer, you've got to be able to provide support for all of these data types and all of these data sources. We at Actian recently implemented our own customer 360 real-time analytics solution. We obviously, as a data company, we have lots of data assets around the organization. And what we wanted to be able to do was to pull all of that data together so that we get a 360-degree view of the account. I mean, the last thing you want is your account rep going in to a customer to propose a new technology, or even to renew an existing contract, only to be surprised by the fact that they've recently had a change of CEO. He's coming in with some different technology ideas, and maybe they've got a customer support case that's escalated. So there's all of these different sources of information that as a rep and you're going into a customer account, it'd be great to have that complete view of exactly what's happening within the engagement. So we built out this platform for use internally so that we could better understand our customers. And to me, it just highlights, I'm not trying to sell you on the solution here, but what it highlights to me is all of the different types of sources of data that we need to pull in and act in to truly understand our customers. So you'll have tools like Zoom Info and Engagio that will tell you, more about the company. From the marketing side of things, we've got Marketo and Drift. We've got ServiceNow for understanding customer service and support, as well as Salesforce. Social behavior, right? LinkedIn. Have they had recent change in staffing? Has somebody come in that's now responsible for the analytics platform that's perhaps going to change things up, right? So really understanding the organization and how it's operating is just really crucial to having that connection with the customer that shows that you really know their business. From a CRM perspective, we see a lot of customers using Salesforce, and then ERP, we've got SAP and NetSuite and Zoho. So these are kind of business applications and business data sources that we want to pull together. And what's really important is understanding that when you're connecting all of these various pieces, that all of these pieces fit together, and that you may have a company. For example, we have a customer in the UK called AA, and that's the Automobile Association in the UK. Here, AAA is the equivalent. But there's also an organization called AA, which is Alcoholics Anonymous, right? So as you're going through these systems and you're pulling information together, you've got to make sure that it matches, right? That you're not combining information for Alcoholics Anonymous and their organization, which is probably hard to find some of that data, but together then with our customer, the Automobile Association. So being able to do that in a coherent way is hugely important, and providing all of the tools to make sense of the data sources is important as well. We'll also find that we've got some streaming data services, we've got some other sources down here in this data and APIs. So just pulling it all together, providing the ability for your business analysts to look at this data to make sense of it, for your non-technical field sales rep to be able to make sense of this, and as they go into an account, they have that holistic view. So just an example of the type of thing that you need to be able to support with a modern data platform. And to me, getting access to all of the data and being able to blend it together in a coherent way is hugely important. Other considerations when it comes to bringing all of your data sources together would be data quality, right? Can I trust the data? Is an opinion that's expressed on Instagram as important as an opinion that's expressed in my CRM system, right? My customer relationship management system. So understanding the quality of the data that you're getting, and oftentimes that's as a result of the source of the data. And then, if the data isn't of quality, how do you correct it? And so we have customers that are in the healthcare space, and they're providing, patient information records. And oftentimes what we'll find is that as a patient is filling out a form, and they're asked for something like weight, right? Or height, or what's wrong with you. The information that you receive will be in various formats, and just trying to make sense of that can be difficult. So that data quality component is hugely important. Data correlation, right? The example I provided to you with the AA being the Automobile Association, as well as being Alcoholics Anonymous, and there's probably multiple other companies that go by those two-letter acronyms, being able to correlate that and make sure that it makes sense. Also, if I have a customer represented in my, let's say, Salesforce system, and then I'm using NetSuite as well, can I make sure that that customer is defined in the same way that when we're matching those two technologies and bringing the data together, and that all makes sense? Data security is hugely important, right? So moving data from some of these source systems does not always make sense, and is not always a good thing to do. This is exacerbated by laws like GDPR, where you should not have multiple copies of the data sitting across your organization. You don't want, Excel spreadsheet dumps of customer data, and a good reason for that is that GDPR gives you the right to be forgotten. And if you ask an organization to remove everything they know about you, they've got to know where that data lives, right, so that they can do that. So that security is important, and then access control, making sure that people can only access the data that they should be able to have access to. So, for instance, for our HR system, I have read, write, access for my engineering organization. I don't have update access. If I want to update that data, I have to submit a request through a form through our people team, right? And then they will go, and they are the only ones in our organization that have that update access to the system. So making sure that, if you're providing a 360 view of a customer or a product or whatever it may be, that if there are parts of that data set that an individual should not have access to, that make sure that you honor that, and they don't in fact have access to it, but probably need to represent the fact that we were unable to provide you with access to the information we took from LinkedIn because you were unauthorized, whatever it may be. Understanding your data retention policy, right? So, as you have built out a platform, maybe it's that you set a policy where you say we'll keep data for 7 years. After 7 years, it goes to cold storage. After 10 years, it gets archived, and we no longer have access to it. But that needs to be part of this, the design of the data architecture. And then the last thing on here is that you need to understand the frequency of data ingestion, right? So as we're updating our data, how frequently does the data change, and does it matter, right? So, if somebody's put a new post out on LinkedIn, do I need to catch it the second it happens? Probably not. If somebody's conducted business with me in my ERP system, do I want to know that as soon as it happens? Well, if they're an account that I'm about to go have a meeting with, it's good to know. Similarly with CRM systems. So understanding the frequency and the importance of changes to that data is hugely important as well. So all of this is encompassed in this. A modern data platform should provide you with access to all of your data sources, regardless of the data type. And these are just some of the things to consider as you think through that. The next is elasticity, right? So we've all now learned that one of the best things about deploying on cloud is its ability to be elastic, so that you can scale and shrink the resources as your business needs change. So, for example, prior to COVID, we only ever talked about business expansion, right? You're coming up to year end, and you want to increase the compute capacity for processing all of the additional deals that you're going to be doing, or transactions that your business is going to conduct. With COVID, we've also seen for some businesses they need to move in an opposite direction. So an example of one of our customers is Lufthansa, the German airline. We had seen them grow and grow, and we were delighted with their success. But when COVID hit, travel was greatly restricted. The travel between certain destinations was prohibited completely. But most people decided that they didn't want to take the risk of traveling. So that business contracted quite dramatically. Right? And being able to contract the resources that you're using as your business shrinks means that you can contain costs. And cloud provides that level of scalability that you can scale out and scale back, that I think businesses appreciate. So I think that's one of the reasons why we're seeing a lot of businesses move to cloud. As hardware refreshes come up, rather than refreshing on-premises hardware, we're seeing a lot of our customers look to cloud infrastructure. We also want to be able to put some level of automation into this elastic scaling. So for instance, some of our customers would request that they don't want anybody waiting for an answer for more than 2 seconds, a completely arbitrary number. And so what you could do is build into your software platform this idea that I have this minimum and maximum wait time. I want it never for anybody to wait more than a certain number of seconds for an answer to come back. But I also may want, I may be okay that if people should wait for 2 seconds. So maybe I don't need a super souped up environment. Maybe I can scale back, but I want to make sure that it's scaled back to an extent that makes sense for the business. So spinning up the resources so that you can manage that average wait time can be important. Some of our accounts like to look at the time taken to complete a specific query. So they have a benchmark query, and they'll say that, maybe it's a grocery retailer, and they have a dashboard that each of their department heads are constantly looking at to understand how the business is going that day. And they want to make sure that that dashboard never takes more than 15 seconds to render. And being able to put a benchmark query in place that says, if we find that it's taking more than that because of increased demand, maybe there's a big game coming up, and we know there's going to be a lot more activity in the produce department. Identifying that this specific query that should take 15 seconds is now taking 30 seconds. Maybe I want to just beef up the compute resources, make sure that we get that back down to 15 seconds, and then as I see activity drop off again, I can scale the environment back down again. And then in some accounts, what they'll ask us for is the ability to scale the environment based upon the number of users. So they will want that, for every 50 users that come in that are transacting business concurrently, they'll want us to spin up an additional set of nodes. So all of these different triggers for growing and shrinking the environment need to be something that's considered as you build out your modern data architecture, if you're building one that should be elastic. And to me, there's no excuse for not building an elastic infrastructure, or there are very few excuses for it. The other thing is, in some organizations, they love all of this to happen magically. In other organizations where they're more focused on cost containment, what they'd actually prefer is that that is something that an administrator needs to authorize. So the system may say, we find that query X is running slow, its average response time is now Y. Would you like us to add this capacity? So some environments would much rather have control over the costs and make sure that the system doesn't, while the system may make suggestions as to how it should grow or shrink, that they want to retain control over that. And then obviously, once this surge in demand dissipates, you want the environment to shrink back to what it would be in its normal steady state. So this elasticity is something that we see a lot in cloud. We see a lot of organizations that are maybe not ready for public cloud, adopting private cloud technologies. And again, you've got the ability for that elasticity in those environments. So as we design our modern data architecture, designing it to be elastic, I think is very important. Next up is our self-service query ability. So this is, providing everybody who's making a decision for the business with access to all of the data that they need to make the best decision for the business, and the toolings that is appropriate for their role to enable them to make that decision. So what we will find is that for technical users, they'll use tools like SQL, languages like SQL. They'll use more complex tools. They may write their own applications using Python and Scala and so on. But what about the non-technical user? What about the person that needs to be able to ask those what-if questions without understanding how that question should be constructed on the back end? So providing support for tools that allow the inquisitive user and the business decision maker to interact with the data in a way that they're comfortable with, we think is really important. So being able to identify the data assets, so that the different data sources that you need to help you make a decision, and then providing a way of phrasing the question that you want answered in such a way that the technology understands it and can serve back up a set of results. So we think that's important, that self-service ability, and a good way of solving that is to make sure that you provide connectivity for a myriad of third-party tools. As an organization, you probably don't want to get into things, most organizations don't want to get into things like natural language processing, right? So if somebody asks a question like, tell me the largest account that we gave the biggest discount to last year for product Y, I can phrase that question in English. I can't necessarily visualize that question as constructed as a SQL query, but I want a tool that's going to be able to do that. So providing support for those third-party tools to be able to interact with your data platform, I think is really important, because we will have less and less sophisticated users interacting with our systems. So we need to make sure that the system is intelligent, so that we can support those less technical business decision makers. And then next up is delivering value on day one. So to us, I've mentioned earlier, I've been in this industry for 30 years, and joined it at a time where you could take on a very large database deployment project that could be measured in years, and that it could take many more years for payback to be realized, right? So for that project to deliver value. What we're seeing now specifically with cloud enablement is that people expect that a data platform should start delivering value on day one. We should be able to measure value and see that value in the first couple of days. So that, I think, is really important. I think that that tolerance for long-running projects is disappearing, and I think people like to see a more sprint type delivery, where we'll say, we're enabling this capability this month, next month we're going to add on that capability, and so on. But every step along the way, you should be able to see the value that's being delivered by the platform. So that's something that that we think that the data architecture should support, that showing value almost straight away. We also see now that since we're talking about cloud and elasticity, that most people now are right-sizing systems, right? So when you spin up your data platform, you want it to be of a size that's going to meet your business needs today. And maybe you predict that your data growth over the next 3 years is going to be a consistent 20%. And maybe you get that number completely wrong. You want that environment to be able to correct some of those assumptions that you've made, right? And to be able to accommodate that greater growth than you perhaps had anticipated. So you want to be able to grow the environment to meet your business needs, and not to have to pay for something that's going to accommodate your peak workload. We at Actian are seeing a lot of customers of database appliance technologies, where companies had taken a bet on or made an investment in a data warehouse appliance, and what they had when they made that purchase, their anticipated data growth for a few years was proven to be too conservative. So those database appliances are filling at a rate that they hadn't anticipated. And so they're getting full. And when a database appliance is full, the typical solution that you'll get from the appliance vendor is that we can roll in another one to sit right next to it. Well, where they're coming to us is that they have tiered their data that's sitting in that appliance. They'll say, our corporate crown jewels are these set of applications. These particular, second set of applications are not as important to us. So what we'd like to do is to move that second tier of applications to a cloud technology, and that will free up some space on the appliance. So those database warehousing appliances are kind of typical of a system that you buy for peak. You have to make a calculation as to what your rate of consumption of the resources are going to be over time, and then you've got to pay for peak the entire time. But if you reach peak early, or if it looks like you're peaking early, you've got to be able to come up with a system whereby you can take some of the pressure off, and cloud technologies give you the ability to do that. And then again, they become truly elastic. The cloud technologies are truly elastic. And the other thing that we're seeing as we build out data platforms is that there's an expectation that you'll only pay for what you use. So if I have a team of data scientists that come in and they work 3 days a week, I only want to pay for the data science infrastructure for those 3 days a week. I don't want to have to pay for infrastructure that's not being used. So that paying for what you use is important. We have a lot of customers that have 24/7 global operations, but what what we will find is that there are periods of inactivity where we want to scale back the resources because maybe we're catching up between the team in Australia and the team here in the US, and maybe there's like an hour or two where there's a lull in activities. Well, being able to scale down the environment to reduce what you're paying, and then to scale up the environment again as the next team comes on board, something that cloud facilitates. We also, with cloud, have many managed services, and the Actian cloud data warehousing solution is a fully managed service. And what that means is that you don't have to have a database administrator, a security administrator, your storage team, your infrastructure management team, and so on, involved in deploying and managing your data infrastructure. What you're able to do here is to allow the provider of this service to fill in those roles, and then what you can focus on is solving your business challenges. So that's another huge benefit of cloud solutions, that they're going to take on a lot of the roles that you previously would have had to train your staff for, and that as you build out the platform, making that assumption that the cloud provider is going to provide those services allows for a better value equation. And then the last thing on here is a lot of people anticipate that because cloud is a commodity platform that has a lot of great benefits built into it, and that they expect commodity pricing. So we went from the average size of one of our data warehousing deals was probably in the region of $250,000. Now, as we move to cloud, we've got customers that are expecting to do $10,000 deals with us, because the expectation is that I can buy 2,000 hours worth of data warehousing, and my business can happily run on that for the next year. So being able to provide that commodity pricing and to build your platform so that it can leverage that commodity pricing, I think is quite important. Cloud platforms have very inexpensive storage, and that storage is very resilient. So why not use that cloud platform for your data storage? So we have seen a lot of our customers move from Hadoop data lakes, where they were using HDFS or Kudu for storing all of their data assets in their data lake. And now they've moved to cloud, because moving to S3 and ADLS and Google Cloud Storage and Dataproc and so on is a much better value equation for them. They're paying, $10, $20 a month per terabyte. So very, very cost effective. And then it's in the cloud. So you've got the level of resiliency and redundancy that the cloud providers guarantee. So that's another really important thing as you design your data platform, is being able to deliver value on day one. And then that leads me to my final point on this, which is resiliency, right? So as you design your data platform, you want to make sure that there isn't a single point of failure in the environment. So it may be that you've got something like let's say in the days of Hadoop, and you had the leader node, right? That leader node could get swamped with activity, and all of a sudden your Hadoop cluster isn't available to the organization. As you build out a data platform, you've got to make sure that you don't have any single points of failure. Build it to be resilient, build it with layers of redundancy in there, so that you can guarantee your 24/7 business operations. We also, as we build out our infrastructure on cloud, we're leveraging some of the great cloud technologies that are available to cloud native solutions, so that if a component were to fail for whatever reason, that it automatically gets replaced, and in a matter of seconds, that fail over to that secondary component has happened, and the business operations just keep happening. So those little blips in operation are barely noticeable unless you're responsible for, from a cloud ops perspective, and you're looking for them. But for the business user that's using your data platform, they don't even see it. And the other great thing about, that you need to think about as you're building a data platform, particularly if you're looking at doing this with cloud, is the fact that you can have your data. By default, it gets replicated, within the same data center. So if a disk were to fail, you wouldn't even notice it. There's a replicated volume available that will kind of fit in for the failed disk. But you can also set up your environment whereby you say, I'm conducting all of my business operations on the East Coast of the US, but what if the data centers along the East Coast suffered a brownout? We had that happen a few years ago. So there's no power across the entire East Coast. I want to make sure that my business operations can continue by having a backup data of my entire data platform available to be spun up in another region, right? So maybe it's in Chicago, maybe it's out in Oregon or something. But as you're designing your data platform, thinking about that resiliency, thinking about your 24/7 business operations, and being a little pessimistic in this, right? Just assuming that everything that can go wrong will go wrong, will help you in designing a resilient system. But cloud has a ton of capability built into it to provide that resiliency. So for me, cloud is kind of a natural fit for a modern data platform. Oops, we have a problem with this slide. One moment while I fix it. So if we were just going to recap on what we talked about just now. One second here. So being able to bring in all of our data our data types and sources, right, is fundamental to building a modern data architecture. Providing elasticity, grow and shrink this architecture as your business needs change. Self-service ability for everybody, whether they're the smartest person in the organization with deep technical skills, or somebody that wants to be able to drill into the data without understanding any coding, without understanding how the data is structured or where it lives, but to be able to ask questions of the data. We think that's really important for modern data architecture. Getting value right away, being able to prove that this solution is going to serve the business and provide value, I think is important. And as I said, the way that we typically will do it is to phase it. So we'll show, on day one, we can deliver value. And then as we build out the platform, it just keeps building upon that. And then resiliency is the last point on here. So building a architecture that has that resiliency built in, that's allowing for the fact that everything's going to go wrong. We have that whole Murphy's Law thing, right? If it can go wrong, it will go wrong. So building your platform for that, we think, is important. And then this is just one of our customers. Actually, I mentioned them earlier, right? The AA, the Automobile Association in the UK, and they've built a modern data architecture. And what this particular solution that we delivered with the AA does is it allows people to enter their information to be provided with an insurance quote. And AA works in those car insurance aggregator sites where you can go in and you provide your information and they'll give you, 10 quotes and you can choose which of those quotes that you want to pursue. They'll ask you for very simple information like your name, your date of birth, your address, and so on, the car's VIN number and everything that they will need to come up with a quote. But that's not what they make the decision on, right? So they'll use your address to understand what are the chances of this car being stolen, right? Is there a lot of vandalism in that neighborhood? So taking that address and expanding on what that tells them about their insurable risk is important. When you provide your name and your date of birth, right? They're able to understand what's your background. Have you had a Dewey in the past? Are you somebody that has a very bad credit record and potentially won't be paying their insurance premiums? The car, has it been in an accident? I mean, just really simple stuff. But they need to take the data that they collect in the form, make sure that it's accurate and formatted, then enrich it from all of these other data sources, and then provide that insurance quote. So they've built a data platform that allows them to pull data from a variety of sources. They can grow and shrink this, right? So there are windows of time in which people spent a lot of time looking for car insurance quotes coming up to the holidays, right? Where everybody, not everybody, but some very fortunate people are maybe getting cars as a holiday gift, and they'll see a spike in activity. When refund checks are issued from the IRS, they'll see a spike in activity. But being able to take all of that into account and grow and shrink the data platform to allow for those changing business demands was important. So to me, this is a great example of a data platform that's built to be modern, that encompasses all of these points that we talk about. So it's all of these various data types. It's elastic. They can grow and shrink this because they've chosen cloud as a platform. They've got this self-service query ability where their their data scientists and their data engineers are in here understanding patterns in the data, but their non-technical users are able to get their answers as well. They saw value right away. As soon as they deployed on our cloud platform, they saw that. And they've got this resiliency built in because they need to support 24/7 business operations. So that's it from me. I'd like to thank you for your time and your interest in what we're doing here at Actian. But more importantly, hopefully you agree with me on these 5 tenets of a modern data architecture. And if you don't, I'd love to continue the conversation. You can find me on LinkedIn, and I'd be very happy to engage.
Perfect. Thank you, Emma. That was fantastic. We are just coming up on time, but I do want to tackle one question. And then if you don't get to your question, you can send it to Emma after the session or look for her perhaps in the networking area. Emma, Rebecca asked, do you observe the same 5 traits for winning architectures of document management systems?
So that's a great question, Rebecca, and I think it would be true of a document management system, right? So being able to get to all of the data, regardless of what that document type might be, being able to grow and shrink it, right? So the number of documents is going to change, being able to get to what you need within the documents with those little nuggets of important information. So yes, many of the traits would be shared here, perhaps not all of them, but many of the traits of a winning document architecture would be shared with that of a data architecture. Yeah, for sure.
Okay, let's do one more. Indra Klein asks, are there any challenges or benefits with regard to data privacy protection regulations?
As a provider of a cloud data warehousing platform, we've had to be very careful about making sure that we can protect customers' personal information, right? So if a customer like the AA, they're collecting a ton of personal information. It's everything from your date of birth, social security number, all of those equivalents, right? So being able to encrypt that data in motion so that nobody could dig into the data as it travels across the wire into the system was important. Encrypting data at rest, so there's no chance of anybody perhaps getting a discarded disk that had failed and being able to get to that information. Being able to provide for what we call dynamic masking, so for sensitive information like the credit card number that you're using to pay your insurance bill, you want to only expose the last 4 digits to a non-authorized user. So that was important. And then when we talked earlier about data access, right? So making sure that only the people that should be able to see your data do have access to that data. So there's a lot to think about when it comes to data privacy. And I think the very large fines that have been put in place for organizations that don't respect data privacy have kind of made organizations pay attention to data privacy and make sure that as you build out a platform that you can comply to the data privacy requirements.
Great. I think on that note, we'll finish here. Thanks again, everyone, for attending. The next session, we'll keep diving into data architectures, specifically real time. Make sure to also check out the networking area where you can find other speakers and continue the conversation. And finally, thank you, Emma.
Thanks so much. Appreciate your time today. Thanks, everybody.